Hello, everyone. Mr. Minnick is my name. Math is my game. And all week long, it's been May. I'm pretty excited. Wednesday was May the 4th be with you. And yesterday was Revenge of the 5th. I don't know what today is, but anyway. Uh, Here we are. I'm joined with my first period Algebra 2 class. They're anticipating, looking forward to seeing the Cavs get defeated in the finals of the NBA championships. Um, anyway, I'll stop talking smack now. Uh, okay. So this first question we're looking at, we're going to graph number one, y equals 0.3 to the x. Some people call me the space cowboy, and some people can't identify A and B here. Um, the B value is 0.3, which if we think about that, that tells us we should be looking at some kind of exponential decay function, but we don't know what the A is, or do we? The A is 1. Good. Since the A is 1, our y-intercept is 1, so the graph goes through that point 0, 1. Now, if you're wondering about any other points, well, it's just like those Glades things that if you have dogs or you smoke, you probably have 10 of them in your house. Plug it in, plug it in. Anybody have the Glades plug-ins? Okay. So anyway, if we were to plug in a 1, we would get 0.3. So the graph goes through the point 1, comma 0.3. If we were to plug in a negative 1, what we would have is 10 thirds. So the graph's going to go through negative 1, comma 10 thirds. Now I know you're thinking 10 thirds, that doesn't even make any sense. Well, yeah, it does. It's 3 and a third. So if we were to go over to negative 1, we'd go up to 3 and a third, okay, which would put us there. And you got to be really good with fractions to be able to graph these without a calculator. If you were to plug in negative 2, you'd have 100 ninths. 100 ninths. What the heck is 100 ninths? Oh no. I don't know. But I think we get enough points to see the idea of what this graph looks like. This graph's going to look like this. The graph's going to look like that. It's going to be really steep on the left. It's going to go like that, and that's it. That's good enough for number one. You were not asked about the domain or the range, but if you had to list them, the domain for number one is all the x's that are possible, and it would be from from negative to positive infinity for the domain. The range would not be, though. Anybody think they know what the range would be on this one? What do we got? 1 to infinity? It kind of seems like it might be 1 to infinity. It clearly goes all the way up to infinity, but the lowest that it goes, it actually doesn't quite go that low. It's like the limbo. It's going to go all the way down to 0. Now, be real careful here. Are we going to count 0 or not? Not count 0 because it's not going to go through 0. So that's what the range would be from 0 to infinity, and it would be parentheses 0 because remember these things never, ever, ever bottom out because of the asymptotal behavior or because of the asymptote. Everybody doing all right so far? Good. Number 2, I'm going to switch up markers on this one. I'll graph this one in green. Living would be easy if your colors were like my dreams, red, gold, and green. This one goes to the point 0, 1 because the y-intercept again is 1 because A is 1. It's that 1 right there that you don't see. If you plug in a 1, 1 times 3 to the first is just 3. So this graph goes to the point 1, 3. If you plug in a 2, you get 9. If you plug in a negative 1, you're going to flip 3 over, and when you flip 3 over, you get a third. So this graph, I think that's enough points to realize quickly that I knew I would, that this world is made up of this brotherhood of man or woman. The domain here is the same, negative to positive infinity. The range is also the same as the last one, 0 to infinity. So if I were to grade one of these on a quiz, the two things I'm looking for, number 1, do you have the y-intercept? Number 2, is your graph the general shape of an exponential growth function in number 2? Okay. We get the idea so far? Good. Number 3, we finally have one with a different A value. Finally, thank goodness. Our A value is 2, which means the graph's going to go through that point 0, 2. Now this is where it gets a little bit weird because when we plug in a 1, it's not just 1 comma 1/5. We have to multiply 1/5 by 2, and when we multiply 1/5 by 2, that's going to give us 2/5. So this graph's going to go through the point 1 2/5. Now 2/5 is 0.4, so it's going to be somewhere right about there. It's kind of tough to do with a big dot like that, but um, and I'm just going to go back the other way. If I plug in a -1, I'm going to flip the 1/5 and make that a 5, and 2 times 5 gives me 10. So this graph goes to the point -1 10, and I think that's enough points to realize that this is an exponential decay function. Its domain is, again, all real numbers, and its range, one more time, is from 0 all the way up to infinity. If you use Desmos to graph those, things that you would need to be real clear with on your graph paper, the y-intercept. Is it increasing? Is it decreasing? Sometimes we're not going to be able to get more than 1 point on either side of the y-intercept, and that's okay. We doing all right? Questions? Knock, knock. Odge. Bless you. Okay, number 4. Uh, 4a is clearly a half. Our y-intercept is going to be a half. If we plug in, people hate fractions. I do too, sometimes. I actually love them, but sometimes I hate them. And the graphing stuff like this, I hate them. 3 times a half is 3 halves, right? Or 1.5. So if I plug in a 1, it's going to be through the point 1.5. If I plugged in a 2, I would have a half of 9, which is 9 halves, or 4.5. So this graph's going to go through the point 2 comma 4.5, which is going to be right about here. If I plugged in a 3, I would have 27 halves, and that isn't even going to fit on my graph. So that's probably enough points right there to realize what this graph's going to look like. Again, it's going to be an exponential growth function. It's growing pretty fast because the rate of growth is 200%. Okay. So the y-intercept, it's an increasing function. It increases pretty rapidly. Okay. Number 5, my a value is 1 again. So the graph goes through 0, 1. If I plug in a 1, I get 2.5. Now, this is why I like fractions instead of decimals sometimes. Well, why don't I make it 5 halves to the t? 5 halves to the x. If I make that 5 halves, if I square that, that's going to be 25 fourths. That's 6.25 for 2. 2 is going to be 6.25. 1, 2, 3, 4, 5, 6.25. If I plug in a -1, I'm going to get 2/5, which is 0.4. We saw that earlier. So this one, again, is going to be an exponential growth function. It's going to look something like that. And there it is. I hope we get the hang of these graphs, do we? Next week, when we look at 7.2, we're going to be translating these things to the right and to the left and to the up and to the down. And we're going to be reflecting them about the x-axis. So all those rules we learned earlier still apply. So, okay. Number 6, our y-intercept once again is a half. If we plug in a 1, we're going to have 2.5. So over 1 and up 2.5. If we plug in a 2, we'd have 25 halves, and that's 12.5, and that doesn't even fit. If we plug in a -1, we'd have a 1/10, and that's not very big. So this one's definitely a growth function. It's growing pretty fast, and there it is. Feeling all right about the graphs? So one thing, if you didn't realize this when you tried the homework, you really need to have a calculator to do some of the evaluation stuff, like number 14. This reminds me of Giselle Bundchen and Ashton Kutcher. Why do models have such weird names? Fabio. That doesn't even make any sense. Fabio. Anyway, if you missed yesterday, we said whenever you write a model, we're going to use a y, an equals, some number a, which is how much we have to start with. So number 14, Our A value is 1,236,000. I know some people don't like to read big numbers. That's okay. Um, Times our B value. If you missed yesterday, we said our B value this way can be found if we talk about growth. B is 1 plus the rate. And in this one, our rate's 1.3%. So this is 1 plus 1.3%. On Monday this week, we took a day out of class to go over how to change percents to decimals. That's 1 plus 0.013. So our B value is 1.013. Did anybody have that for the B value? Awesome. If you didn't, check yourself before you wreck yourself. So, talking about a model. Models have y's in them. Models have something else for the exponent. What exponent am I going to use? I heard somebody say 10. I heard somebody else say something else. T. When we write the model, we got to use T. So this is the answer to the first half of the question. Write an exponential model. Got him. The second half says, now find each amount after the specified time. So now we'll go ahead and plug in 10 and see what happens. So you are going to need a calculator capable of exponentiating 1,236,000 times 1 plus 1.3%. Ah, you could do that? Yeah, you can. Do you see what I did there on the Inspire? To the 10th. Because some of you are going to take 1 plus 1.3% and you're going to mess that up. I'm not saying you suck at changing percents to decimals, but somebody's going to mess that up at one point. So you can actually have the calculator do that for you if you don't feel confident in your abilities to do that. So we're looking at 1,406,413 and change. And we need to talk about the and change today. We need to talk about the and change today. So we're talking about people. And we're talking about people. So if we have 1,406,413.16924 people, what I would like to think about for a second is 0.16924 people. That's approximately 1/6 of a person. So imagine cutting a person into half. Then imagine cutting that half into thirds. Is that a person? Well, what if that 1/3, the 1/6 that's left is their head? That's a person, right? When we're talking about people, anything living, we need to use what's known as a chop-off method of rounding. Round to the nearest whole number, chop off. If the decimal portion is 0.5, don't round up. With people, with living things like squirrels and snakes, and I know you hate snakes, and I know snakes can still slither if you cut them in half. Irregardless. Yes. Chickens run around also. Yeah. 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 The animals are very resilient. So anyway, the point is, if we're talking about living things, use a chop-off method of rounding, okay? Any questions about that? Okay, number 15 then, we're talking about a population decreasing. 15 is going to be y equals 752,000 times. Here we're going to use b is 1 minus r, 1 minus 1.4%. So here's a common mistake that people want to make here. People want to put in for their b value 0.014. Is that right? Heck no, it's not right. 1.4% is just a little bit of decay. And a little bit of decay means that the b value's got to be real close to 1, and 0.014 is nowhere near 1. Does that make sense? I hope so. And then, so I got to get the right one. I'm going to raise this to the t power. Okay, so I'll go back to my Inspire. What was it? 1 minus 1.4%. So that's 0.986 is what we should be using for our B here. 0.986. 0.986. Okay, so again, this is the answer to the first half of the question. To get the second half of the question, we're going to plug in an 18. So 752,000 times 0.014. Somebody should call me out. Huh? There's a percent there? I put in the wrong one? Well, let's just see what happens. There are 0.00000000000000000. I lost track. Imagine a zero with a point and 27 leading zeros. There's 3, 1. I don't even know what that would be. It wouldn't be quadrillion. I don't even know. There's less than one person left. Everybody's gone. Everybody's gone. We have a fingernail left. We have 1/1000th of a fingernail left. Do you see how using the wrong b-value really screws this up? When you take this quiz on next week over this, you're going to do that. You're going to use the wrong b-value. Don't. Make sure you use the right b-value, okay? Make sure you use the right b-value. The right b-value is 0.986. Okay. So there it is. That seems more reasonable. If we started with 700,000, that we're somewhere in the 500,000 range. That seems more reasonable. And apparently I can't cut things out too well. So let's try that again. All right, so the second part of this, again, we use a chop-off method of rounding. You should have had 583,448 people. Anybody have that? Good. Questions, comments, concerns about it? Well, this next one is a new car, and most vehicles depreciate. So our model, we're going to write y equals 18,000 times. I think we got the hang of this. What's our b value going to be now? 0.75. Awesome. So that's the answer to the first half. That's the answer to the first half, the model part of it. Okay. So we're going to plug in 18,000 times 0.75, and we're raising it to the fourth, to the fourth, and we get, oh man, that's not even nice at all. That just doesn't seem fair, does it? You've been making a payment on this car, $18,000 car. Your payment's probably going to be about $300 a month. You pay $300 a month on this car, and at the end of 4 years, you want to sell it, and you still owe $8,000 on it, but it's worth $5,695. Cars depreciate as the second you drive them off the lot. I could tell you a story, but it's pretty depressing, and I don't want to depress anybody today. But I would like to tell another knock-knock joke. Knock-knock. Owls. I know. When we're talking about money, we need a dollar sign. When we're talking about money, we need to go out to 2 decimal points. The 31 cents is kind of negligible, but we still need to go to dollars and cents unless otherwise noted. Any questions about 14 or 15 or 16? Or about depreciation? Okay. Well, this section should go pretty quickly. Without graphing, determine whether this is growth or decay. I'm just going to abbreviate with a G or a D. G for growth, D for decay. I'll set these up to infinitely clone, if it lets me. There we go, infinite cloner, infinite cloner. Remember, we're looking at the b value. The b value is the thingy that's raised to the power x. So here we're looking at a third, 5/4, 1.05, 6 over 5, 1 hizzy, 1.75. Remember, if that's bigger than 1, then we have growth. So We're going to have growth for number 9, growth for number 11, growth for number 8, and growth for number 12, right? And then 7, we're going to have decay there. 10 is decay. And they also want the y-intercept. And whenever they want the y-intercept, that's just the a value. That's just the a value. Now, I'll be frank with you, even though my name's not Frank. When you write the y-intercept, if you just wrote 0.99, fine. If you want to put it in an ordered pair, that's better. But if you just wrote the a value, that's fine. But technically, it is this ordered pair. Okay. So that would be a better answer. So 8 would be 0, 20. 9 would be 0, 2/3. And 10 would be 0, 1/5. Or 12, I mean. Sorry. And that's it. How does everybody feel about those? Copacetic? Macadocious? Does anybody even talk like that anymore? In 92, that was the word. Macadocious. That's like you're feeling pretty fresh, pretty dapper, pretty fly, pretty hip, pretty happening. Macadocious. Like you could just walk into the mall and everybody would be flocking towards you like you're King Tut or something. Macadocious. Okay, they didn't ask you what the rate of growth or decay is, but I'd just like to look at each one of these and talk about the rate. Number 7, does anybody think they know what the rate of decay would be in 7? Bueller. Bueller. What would the rate of decay be in problem number 7? Remember, if we're finding the decay rate, we take 1 minus the b. And then we make that a percent. What do we got? It would be 2/3 and then convert it to a percent. So it'd be 66 and 2/3%, right? So the decay rate, they didn't ask you to find it, but if they did, the decay rate would be 66 and 2/3% for number 7. What about number 8? What about the growth rate there? What about the growth rate in number 8? For growth rate, you take the b and you subtract 1, and then you make that a percent. So what do we got? Bueller. Would it be 25%? Well, we're taking the b, which is 1.75. I'm looking at 8. 1.75, and 1.75 minus 1 would be 0.75. So we'd be changing 0.75 into a percent. So on number 8, the growth rate would be 75%. Number 9, the growth rate would actually be 25%. Number 10 is easy. You can't miss that one either way you do it. Number 10, the growth rate would be 50%. Number 11, what would the growth rate be in number 11? Number 11, it would be 5%, right? And 12, the growth rate would be 20%. Where'd you get 20%? Well, 6/5 is 1.2, and 1.2 minus 1 is 0.2, and 0.2 converted to a percent is 20%. There will be questions on that quiz where you're going to have to do this. Find whether it's growth or decay and what the rate is. So make sure you can do that. I don't know if Math Excel has you doing that or not, but make sure you have that skill in your back pocket. Okay. 29. Does 29 ask me to write a model? I would like to share with you what's going to transpire on the quiz. There's going to be a question like 29 on the quiz. And you know what? Some of you are going to write the answer. Some of you are going to write the answer. So what you're going to do is you're going to take this 29,000. It's depreciating 12% per year. And you're going to put the answer down. What's the value of the truck after 7 years? So 29,000. Watch this. 1 minus, what was that rate? 12%? 1 minus 12%. And after how many years? 7? Oh, no, I don't know how to use the TI Inspire. How do I get a decimal? Control, enter, right? So here's what will transpire on that quiz. I hope that you make a liar out of me, okay? But I only lie when I'm on my back, sometimes on my side. Anyway, number 29, if you put this for the answer, 11851.59, that's going to be wrong, and you'll lose 4 points. If you think that that's going to round to 60 cents and you round it to 60 cents and you put a dollar sign, that's going to be wrong and you'll lose 4 points. Maybe you aren't that good at converting percents to decimals and then subtracting. So maybe you do this. Maybe you do this. And you say the answer is 1 cent. And you say the answer is 1 cent. But you have 29,000 times something to the 7th. I'd probably give you 3 or 4 points if you had that much. Do you see the difference? I'm not asking you to write a model. They're not asking you to write a model, but you're showing evidence that you kind of have an idea of how the problem gets set up. You understand what the A is, you understand what the T is, and you just drop the ball on the B. If you had this, I'd give you 4 out of 5 points, maybe even 5, even if your answer was wrong. If you had this, same thing. I'd give you 4, maybe even 5 out of 5 points, even if your answer was wrong. So the point is, if you're doing these, make sure you kind of show what it is you punched into the calculator, because people make calculator mistakes all the time. Just like cell phones. How many times have you went to text somebody and you say, be safe, and your stupid autocorrect says, be sage? Yeah, that makes a lot of sense. I'd like you to be sage while you're driving. Stupid autocorrect. Number 30, the price of a new home. A new home. It's appreciating. 350,000 times 1 plus 2%, so 0.02 to the 10th. There we go. $350,000 house. That's a pretty big house around here, ain't it? 350,000. 1 plus 2% to the 10th. To the 10th. Oh, man, I suck at using the Inspire. What should I press? Control Enter will give me a decimal. Dollars and cents. We got to go 2 places. We got to round the right way. That's $426,648. And how many cents? I'm hearing 4, I'm hearing 5. $426,648.05. With money, we use the traditional rules of rounding. Okay. 31. They got a part A asks for the model, part B asks for something about 100 years later. So 31A, the model, y equals 200,000. Decreasing at a rate of, if you honestly, if you just wrote 1 minus 0.75% to the t, if you left it like that, I would probably give you full credit for the model, honestly. Even if you didn't convert the percent to a decimal. Because I'll be honest with you, most of you are going to, if you try doing that in your head, you're going to mess it up. Not all of you. Anybody know what that B value would be there? 0.9925, you think? Let's find out. 1 minus 0.75%. Right on, nice. So our B value there is 0.9925. So they would have us at something about 100 years, right? 200,000 times 0.9925 to the 100th to the 100th. We're talking about the voids here, not the B's, just the voids. So how are we going to round that? Because it's a living, breathing thing. We're going to use chop off rounding because it's a living, breathing thing. 94,206 voids in 100 years. Doing all right? Okay, almost done. We are done. That's it, right? It's been real. It's been fun. I'd like to give a shout out to the future Mr. Minnick. You're awesome. I hope you have a great weekend. I'd like to give a shout out to this guy, Marky Mark and the Funky Bunch, to Mr. Jones. I miss him. And I hope everybody has an awesome weekend. If you're in track, good luck. If you're in baseball, softball, good luck. And if you're going to go have a barbecue at your mother's house for Mother's Day, have fun. Kiss your mom, buy her flowers, give her a card, tell her you love her. And if you don't like your mom, still do that stuff. Have a great day.